Hello students, we'll start lecture 2 of the chapter Force and Laws of Motion. So already we have studied what is force and types of forces. Force means whenever you are just applying push or pull, that is the force. But apart from this, also we have seen that there is some gravitational force and there are two types of force, contact force and non-contact force. Again, for the contact force, we are giving another types of the force, that was muscular force, that is gravitational force, and also electromagnetic force. So many forces we will discuss here. So in this chapter, just a minute. Yes. So in this chapter, we will cover in this lecture, that is non-contact force, and the different types of the non-contact forces we will discuss here. Let's start. Now, non-contact force, in the name also, from the name we can understand this, we are not touching any object here, but still there is some force acting on the object, right? So the forces that act through the spaces without making any direct contact with the body or object are called non-contact forces. Just a minute. I'm just taking the highlighter. So this point is very important. Without making direct contact. That means for the non-contact force, you are not going to be in contact with the object. So that is non-contact force. Like when you are skydiving, at that time you can see that the person, he or she, is floating in the air. So this is due to the gravitational force. But here you can see that the gravitational force, if this is the gravitational force, that you cannot see that the man is applying the gravitational force or the gravitational force that has been applied to the man with a contact, right? And in this is the electrostatic force. Now, this is a very good example in our daily life. Whenever you are using the comb, at that time, you can see that after certain time, whenever some electrostatic force will be there and the charge will be there, and just you just place here some piece of paper, at that time you can see that it will attract the pieces of the papers. So that means there is these pieces of the paper, it is not in the contact with the comb. But you can see that there is some attraction and you can collect all the pieces of papers using this comb. So there is some charges have been developed here, and this is the electrostatic force. It is also another type of non-contact force. Because here the comb, it is not in a contact with the pieces of the papers. Okay. Then this is the magnetic force, and you have seen, suppose you have some bar magnet here. And there is some nails. Just a minute. I'm taking the pen. There is some nail here at a distance. There is some nail here. There may be some nail here, or pin also you can use. So here you can see that this is the magnet. You are taking one magnet and these are the nails. Okay, so this magnet will attract all the nails. And for alpine also you can see this experiment. And here this is the magnet in this figure, that this one is our nail and made up of iron. A portion of the iron you have in case of our alpine also. Some percentage you have. Here you have some magnet where S is the south pole and N is the north pole. Here I am writing this thing. This is the north pole. of the magnet, and this one is the south pole of the magnet. Okay, so this one is our magnet. This one is our magnet, right? And this is the north pole, this is the south pole. And the south pole and north pole both are attracting each other. And here, if you are keeping one nail, you can see that this nail will be attracted by the magnet. But this nail, it is not in contact with the magnet. The magnet is attracting or applying the force. Attracting means what? It will pull that thing. It will pull the nail. So it is just giving the force, or it is just applying the force, pull or push, I have told you. So here pull will be applicable. So it is not in contact with the nail, but with a distance. There is some distance in between the nail and the magnet. Here you can see that here the magnet is attracting the nails from a distance, right? And how much distance will be in between these two to attract this, that depends on the strength of the magnet, right? So we have studied in this slide that there are several types of non-contact forces. In your daily life, you can see skydiving, you can see the comb where you are just using several times. After that, you just keep pieces of paper on table and just you try to touch the comb very near, but don't make any contact with the papers. So very near, you just keep the comb, then you can see that it will attract the pieces of the paper. And similarly, if you are keeping one magnet and nearby some iron objects are there, nails, or you have another iron object, so you can see that this will be at that time attracted. Okay, the nails will be attracted. So these are the non-contact force, because we are not touching this object. This object where I am applying the push or pull, I am not touching this. So this is the non-contact force. Clear? Now, several examples of the non-contact force just we have described: gravitational force, electrostatic force, magnetic force. Electrostatic force also you can see in your cloth in the winter time. Magnetic force always you can see in your physics laboratory, or you can see that sometimes to segregate some iron parts from any garbage. So we can use the magnet also, right? And gravitational force, that is non-contact force. If someone is doing a skydiving, or also you can feel the gravitational force if you are throwing any ball, at that time also you can see the effect of the gravitational force. Always whenever you are throwing one ball upward, that ball will come towards the ground. That ball will come towards the ground due to the gravitational force. Okay. So now I am just giving a very good explanation here, that is magnetic force. Now the force exerted by a magnet on other magnets is called the magnetic force. Magnetic force and electrostatic force act on an object from a distance. That's the reason they are non-contact force. Already I have told you, non-contact force means the object is not in a contact with the force. From a certain distance, it will apply the force. It may be push or pull, but it will apply the force from a certain distance. So this is the magnetic force, where this one is the magnet and this is the north pole and this will be the south pole. These are the screws, okay? And in that screw also you have a part here, some iron has been mixed here. So you can see that if you are keeping that screws here, at that time the magnet, this magnet, it will collect all the screws, or it will attract all the screws, and you can see that from certain distance it will jump to here, and after certain time you can see that it will be attached to the north pole or south. Okay, so this is the magnetic force. This is the magnetic force. Now these lines, these are the magnetic field. These lines, this is the magnetic field. Okay, these lines. These are the magnetic fields. Now, if I am keeping one charge Q on the magnetic field, at that time, there will be some velocity, and the velocity will be in this direction, where the magnetic force in this direction. Okay, and here the B is the magnetic field. So how much force has been applied to the charge Q? How much force? That is the charge Q into V. What will be the velocity and what will be the magnetic field you are applying? If your magnetic field is strong, that means B is very high amount. At that time you can see that the force is also very strong. If the magnetic field is weak, at that time your force will be less. Okay. So the force in the magnetic field, that is related to the charge Q, and V, that is the velocity of the charge, and B, that will be the magnetic field. Okay. So this is the magnetic force. Now the gravitational force here, just a minute. The strength of gravity is an attractive force that is exerted by the earth on objects. In this earth, whatever the objects you have in this surface, whatever it may be, your tree, it may be one person, it may be any kite or whatever you have, all the things, it may be tower, so all the things that you have on the surface of the earth, they will be attracted by the gravitational force. So here you can see that in this case, if you have some apples in the apple tree, this will fall downward. And if one body or object you are keeping, at that time the weight of the body is the force that is pulled by the earth towards the center. Suppose this is our table where I am just keeping one object. Right? This object, it has some weight, okay, W. So it has some weight, and this weight of the object or the block, that is the force that is pulled by the earth. Okay, weight of the object, right? And it will be pulled by g amount of the acceleration. So here some gravitational force will be acted on the body or the object that is in the rest on the table, and the weight of the body is the force that is pulled by the earth towards its center. Similarly, you can see for the aeroplane, you can see for the person who is skydiving here, and this is the ground. So you can see that he or she, he will fall down. So that is the due to the gravitational force. Okay. Now types of forces. Types of forces that already we have discussed: magnetic force, gravitational force. Now if you have two objects having the mass m1, just a minute, having the mass m1, so here m1 is the mass of first object or sphere, and m2, that is mass of second object, F1, that is the force of first object, towards M2 object, and F2, that is the force of second M2 object, force applied by the M2 object to our M1 object, right? So this force is the force applied by the M2 object, and F1 is the force applied by the M1 object. And the distance between are, this is the distance between M1 object or sphere and M2 object, okay, or sphere. So our F1 equal to F2, that means that will be G into M1 M2 by R square. That means your F is, here I am writing, your force that is proportional to M1 into M2 and force that is inversely proportional to R square, distance square of the distance. And G is the universal constant and it has the value 6.674 into 10 to the power minus 11 Newton meter square per kg square. So the force whatever applied, that force, the force between this M1 and M2, that will be our G into M1 M2 by Rh square. That means your force will be proportional to the product of M1 M2 and inversely proportional to the square of the distance. Next, electromagnetic force. In the electromagnetic force, here I am applying some battery here, where this is the positive and this is the negative side of the battery, and one nail is here where you are coiling the nail. At that time, if you are switching on this battery or connecting this battery, you can see that some magnetic lines of force will be here, and it is very important. See this picture very carefully. The lines of force, the magnetic lines of force that is coming out from the north side and it is penetrating in the south side. Okay, that means just a minute. I'm just changing the ink color. So which one? Fine. So here you can see that in this way you have the direction of the magnetic lines of force. Okay. So electromagnetic force, it is the force exerted by two charged particles on each other. If you have two charged particles, this is positive charge, this is positive charge, there is some force acting on this. So here maybe attraction or maybe some other force, that means they will pull each other or they will push each other. So that is different, but there is some force will be exerted by two charged particles on each other. So here this is the electromagnetic force. If I am keeping some positive charge here and some negative charge here, at that time you can see that they will attract each other. And whenever I am just keeping two similar type of charges, that means two positive charges, at that time they will repel each other. And here it will attract each other. If different types of charges I am keeping in very close proximity, right? So this is the electromagnetic force. Now the nuclear force. Here, as you know that in any atom there are some nucleus and the parts whatever you have, that is neutron, proton and electron. And electrons, they are always will be in the outer shells, but nucleus, that means you have neutron and proton and they are very tightly bounded. So nuclear force, this is also known as the strong force or nuclear interactions. Every atom you have neutron and proton. Here you can see that the blue whatever, that is neutron, and the red one, that is the proton. So here you can see if one proton and neutron is nearby, they will attract each other. If two neutrons are nearby, they will repel each other. So this is the nuclear force. And this nuclear force sometimes we are using for nuclear fusion. At that time also we are using. And this nuclear force we are using it whenever we are making some atom bomb also. right? So this is very, very important, and this is the strongest force, I think. So nuclear force that is responsible for binding the neutrons and protons in an atom together. So here, this is the nuclear force, right? So whatever the nuclear force, that means it is in between the neutron and the proton that you have inside the nucleus, okay, inside the nucleus. Now the weak force. Here you have the nuclear force, as just now we have studied. Some strong force is there, and that is between the neutron and proton. Sometimes a neutron changes itself to a proton and it emits an electron and a particle that is called antineutrino. Okay. So just a minute, I'm taking the highlighter. Antineutrino. Okay. So sometimes here in this case you can see that here's a neutron that will change itself to a proton. At that time it will emit an electron, and this particle is called antineutrino. And this process is called beta decay. And weak forces that are responsible for such decays and interactions. And this weak forces is actually force of attraction that work at an even shorter range of 0.1% of the diameter of the proton. Now here I want to mention one thing, that is the charge radius of, is it visible? I think I have to change the ink. It's not so much visible here. Just a minute. So here the charge size, in the same color. Just a minute. Just change the ink color. Okay, fine. So here the charge size, this is C. Okay. The charge size that equals to 0.8414 femtometer. That means 0.8414 into 10 to the power minus 15 meter. Okay. So this much is the charge size of the proton. Okay. This is for proton. Now what it has been told that the weak force is actually force of attraction that work at an even shorter range, that is 0.1% of the diameter of proton. So what will be the 0.1% of this size? Very, very, very small. So within this small distance, or within this small size, you can see that your weak force is that will act. And the force which are responsible for such a process differ from the gravitational, electromagnetic or nuclear forces. And these forces is actually called weak force. Fine. So this is the weak force, and you can see that it will act with a very short distance, that it cannot act from a very high distance. This distance is very, very small, that is 0.1% of the diameter of the proton. Now let's solve this problem. Numerical. Okay. So let's find out the solution. Here, how much net force is required to accelerate a 1000 kg car at 4 meter per second square? So here, first, already I have told you, first thing, what are the given data you have? Here it has been given mass of car, that is 1000 kg, and Mass of the car is 1000 kg and the acceleration I'm denoting using A, and mass of the car, let's we denote using M. Okay, acceleration, that is 4 meter per second square. 4 meter per second square. So now we have to find out the mass. We have to find out the force. So let's force is denoted by F. So here the force equals to M A. The mass of the car is 1000 kg and acceleration is 4 meter per second square. So it is our 4000 kg meter per second square, or I can say this is our 4000 Newton. 4000 Newton, and this is the answer. Okay. Next one, Amy has a toy car. Fine. Toy car. Mass of 2 kg. So first, whatever the data I am just getting from this question, that I am writing here. So mass of toy car, that is denoted by M, 2 kg. How much force should she apply on the car so that it should travel with the acceleration of 8 meter per second square? So acceleration, that is denoted by 8 meter per second square. That means force F, that equals to M into A. I can write down 2 kg 8 meter per second square. So it will be 16 kg meter per second square, or you can write 16 Newton. Okay, so this will be the answer. Next, what is the line of action of the force? Line of action, see this figure very carefully. Just a minute, I'm changing the color. Here we have some point of action. This is the point of action where I am applying the force, and this is the line of action. So the line along which a force is acting on the object, that is called line of action of the force. So what is line of action? Along which line you are applying the force on the object. Along which line you are applying the force on the object, that is the line of action of the force. And the point where the force is acting on the object, this is the application of the force. Point of application of the force or point of action. And the force which opposes the relative motion between the surfaces of two objects in contact and acts along the surface is called force of friction. Always you know that if this is the ground and you are keeping one object here, one block here, this is the point of contact. This is the point of contact, and in this point of contact the frictional force will be active. So this is the force of friction, the force which opposes the relative motion between the surface of two objects. One object is what? Ground. Another object is what? Your ball. Or another object is the block which you want to slide, so that, or which you want to move. So this is the second object, and first object, this is the ground. This is the ground. Suppose it may be you are keeping one block on the table. So table is the one object and block or the box, that is the another object. So in between these two objects, whatever the forces are acting, that is the frictional force. In between the surfaces of these two objects which are in contact, that is the frictional force or force of friction. Okay. So now it is very clear, line of action, along which line you are applying the force, at which point you are applying the force, that is very important, and frictional force, that is also important. Now, Galileo experimentally proved that objects that are in motion move with a constant speed when there is no force acting on it. And he could note that when a sphere is rolling down an inclined plane, its speed increasing because gravitational pull which is acting on it. Suppose this is a slanting plane here, and this is the ground. Let this is the ground, and you are just one ball here, and it will roll. Okay, it will, that is rolling down in following this plane. So you can see that the speed will increase because this is the height where your gravitational force that is acting on this object. And when it will be here, you can see that when it will be here, you can see that this is the height from where the gravitational pull will be acting, right? So here it is much closer. So that means your speed will increase whenever it is just rolling down to an inclined plane. Okay. So this experiment Galileo, this experiment he done here. Now this is the experiment of Galileo. Now few questions now we like to discuss. Which is the weakest force in nature? The weakest force in nature, just a minute. I'm taking the highlighter. Gravity is the weakest force in the nature. The strongest force, just now we have studied that nuclear force. 100 times stronger than electromagnetic force. What are the some types of forces? Obviously, you can write down the answer: contact force, non-contact force, electromagnetic force. You can write down muscular force. You can write down different types of non-contact force, magnetic force, different types of contact force, frictional force also you can write down. So here, if they will ask you some types of forces, just write down to main category or subcategory also you can write. Now some examples of the force, that is the gravitational force, electric force, magnetic force, nuclear force, frictional force. Here electric force, that you are applying for the movement of the electron. That is the electric force. Which force causes a charged balloon to attract another balloon? That is the electrostatic force. If you have one balloon here, and if you have another balloon here, you can see that some charged particle will be here, some charged particle will be here, that will attract each other. So that is the electrostatic force. Electrostatic force. Now what will be the, okay, again some numerical. Just a minute, I have to change the color and I have to take the pen. Give me some time. Okay. What will be the acceleration of the body of mass 5 kg if the force is 200 Newton is applied? So let's find out solution. Very easy this thing. Now here it has been given force that equals to 200 Newton and mass that m equals to 5 kg. Okay. So what will be the acceleration? Let acceleration we will denote using A. What will be the acceleration here? So here you can see that if F equals to ma, That means A equals to F by M, right? So acceleration, that equals to, how much is the force? 200 Newton. What is the mass? 5 kg. Both are SI unit. So no problem. So acceleration here, that will be 40 meter per second square. This is the answer. Next, a bullet of mass 10 gram is fired from the rifle and takes 0.003 second to move through its barrel, leaves with the velocity 300 meter per second. What is the force exerted on the bullet by the rifle? So here, let's find out the solution. Mass of bullet M, that equals to 10 gram. First we are trying to find out this in kg. So that is 0.01 kg. Then they have given time t equals to 0.003 second and velocity v, that equals to 300 meter per second. Here, this is the final velocity. Let initial velocity before throwing the bullet u, that equals to 0 meter per second. So here F equals to, you know that F is the force, M into A, or acceleration is the V minus u divided by T. Final velocity minus initial velocity divided by T. So how much is the mass? 0.01 kg. How much is the V? 300. How much is u? 0. How much is the T? 0.003 second. So let's, I'm doing here F, that equals to 1000 Newton. And this is the answer. Okay. Now, what is the force would be needed to produce an acceleration 1 meter per second square on a ball of mass 1 kg? So here, acceleration A, that is 1 meter per second square, and mass M, that is 1 kg. So the force F, that equals to M into A. So it will be our 1 into 1, that means 1 Newton. So this will be the answer. Very simple. What is the acceleration produced by a force 5 Newton exerted on an object of mass 10 kg? So here it has been given solution. It has been given force, that F equals to 5 Newton. Mass equals to, mass is denoted by M, 10 kg. So here acceleration equals to F by M, that means 5 by 10 kg, 0.5. Just a minute. I think it is not so much clear. This 0 is very much small, right? There should be big zeros here, but not in your exam paper. 0.5 meter per second square. Okay, 0.5 meter per second square. Right? Next, how long should a force 100 Newton act on? Let's solve this one. Force 100 Newton. So F, that is 100 Newton, act on a body of 20 kg. So mass M, that equals to 20 kg, so that it acquires the velocity of 100 meter per second. So velocity V is the 100 meter per second. So that means how long? What is the question? How long? So we have to find out the time. Let time is denoted by T. So we have to find out this one. Now you know that force equals to mass into acceleration, and mass, that is the 20 kg, and acceleration equals to u v minus u by t, where v is the final velocity, u is the initial velocity, t is the time. So I can write down here 20 and v is the 100, initial velocity was 0, and time is how much they have given, that you have to find out. Here the force has been given 100 Newton. So that means I am writing here 20 into 100 minus 0 divided by t, that equals to 100 Newton. So from here we can write down 20 into 100 divided by t, that equals to 100. So t into 100, that equals to 20 into 100. It implies t equals to 20 into 100 divided by 100. So this 100 will be cancelled. That means t equals to 20 seconds. And this is the answer. Okay. T equals to 20 seconds. Next. Here, let's find out the solution. 1000 kg vehicle moving with its speed 20 meter per second brought to rest. That means final velocity is 0 in a distance of 50 meter. In a distance of 50 meter. First thing we have to find out the acceleration, right? What are the given data? Mass is the 1000 kg. Fine. Here, the velocity, this is the initial velocity because it comes to rest, meter per second. Final velocity v equals to 0 meter per second, and distance s equals to 50 meter. And we have to find out the acceleration a. Okay. So we know the third law of motion, from where v square equals to u square plus 2as. V is the final velocity, u is the initial velocity, plus 2as, a is the acceleration, s is the distance. So from here, s equals to v square minus u square divided by twice a. Okay. So s equals to v square minus u square by twice a. Now if I want to find out the acceleration a, that means acceleration a, that equals to v square minus u square divided by twice s. I am doing here. So acceleration, that equals to v equals to 0, u equals to 20, so 20 square, and 2 into s, that is our 50. So acceleration equals to minus 4 meter per second square. So this is the first answer, right? Now the second one, calculate the unbalanced force acting on the vehicle. Unbalanced force acting on the vehicle. So for the second bit, F equals to m into a, we know that force equals to mass into acceleration. So mass is how much? It has been given 1000 kg. So we can write down 1000 with multiplied with the minus 4. So that means it will be our minus 4000 kg meter per second square. Kg meter per second square. Okay. Or minus 4000 1000 Newton. That means this force, this minus is for the direction. So I can write down the magnitude of the force is 4000 Newton. The magnitude of the force is 4000 Newton. Next, point 3, bit 3. Here, the actual force applied by the brakes may be slightly less than that calculated in. Why? Give reason. So, why it is less? Because there is some frictional force is also acting. If the vehicle is moving and you are just, this vehicle will come to rest. That means it is why? Due to the friction, right? And you are applying the force also. So, here you can write down due to force of friction, due to force of friction, the actual force applied by brakes may be slightly less than calculated one. Okay, that's all this one. Next, another solution we have to do, that is here which would require greater force. Accelerating a 10 gram mass at 5 meter per second square, another 20 gram mass at 2 meter per second square. Fine. First mass is the M1, that is 10 gram converted into kg, that means 0.0. Sorry, just a minute. Just a minute. Okay, 0.01 kg. Okay, and the acceleration A1, that equals to your 5 meter per second square. So if the force is F1, then M1 into A1. So this will be our 0.01 into 5. That means F1 equals to our, how much? F1 will be our 0.05 Newton. Okay. Similarly, F2 equals to M2 into A2, where M2 is the, how much? M2 is your 20 gram. So I'm doing here, M2 is the 20 gram, that means 0.02 kg. So I'm applying 0.02. Acceleration A2, that is the 2 meter per second square. So it is 2. That means it will be 0.04 Newton. Right? So here you can see that F1 is greater than F2. Hence, more force is required to accelerate 10 gram at 5 meter per second square, then accelerating 20 gram at 2 meter per second square. Okay, fine. So here you can see that F1 is greater than F2. Thank you. And in the next class, we will continue this chapter.